Okay, so we're looking at page 19, example 4. And I started this in class and we talked about a couple things. First of all, this was 0 and this was pi. And this is pi over 2. We know that basically this is going to be wherever it reaches to the height. So we had a equals b times h, and we said that the height is going to be equal to sine x. So no matter where, if our rectangle looks like this, that's what, so if that's what our rectangle looks like, then this is where it's going to reach. But it's still always going to be on the sine curve. Okay. Now the other part that we need to consider is the base. Okay, so the base, now, if you look at, here is 0, and let's say, hypothetically, let's say that that's where, that's going to be the spot that's going to maximize the rectangle. So this is x, and since this is symmetrical, this is also x. So if I'm looking at this length right here, if I'm looking at that height, or length, excuse me, all the way across this pi, from 0 to pi, so if I'm taking away an x on each side, then this can be represented by pi minus 2x. So the base is pi minus 2x. So now that I could take that formula, so we have a function just in terms of x, so it's base times height. So pi minus 2x times sine x. So I want to do the derivative because we want to maximize that. Now you could distribute, or we could also just do the product rule. So I'm going to do product rule. So I have pi minus 2x times the derivative of sine, which is cosine, plus the derivative of the first part is going to be negative 2 times the sine of x. So I'm going to have to set this, since let me just clean this up a little bit. So it's going to be pi cosine x minus 2x cosine x minus 2 sine x. So I want to set this equal to 0. Okay, so I'm going to go to my y equals. So I have pi cosine x minus 2x cosine x minus 2 sine x. And I want to make sure, first of all, I want to make sure that it is in radians. Oops. And then when I do, I'm actually going to make the window match what I can see right here. So the window is going to be from 0 to pi. And I'm going to make this 0 to, or actually they have negative 0.5. Oops, X scale I want to be 1. So negative 0.5, and then X max is going to be 1.5. So it should give me the similar graph to what I see, or I'm sorry, it's going to graph it within the same window, but this is the derivative. So I'm going to look at this point. So I want to find the 0. Now I notice that it crosses at 2 points. This point over here isn't going to work. So I'm just going to look at, because this point won't make sense in terms of the domain. So we get 0.710. So we can, so here's 0. Obviously we can't have anything bigger than pi, but I'm just going to check 0.710, and we can plug in a value. Again, this is going to be a calculator type problem, but this will give us plus and this will give us minus. So it is a maximum. So what is the largest area the rectangle can have? Well, we can plug back into the original. So if I plug 0.710 into here, we'll have pi minus 2 times 0.710 times sine of 0.710, and we get about 1.11, and we don't know what the units are, so we'll just put units squared. And the dimensions, did it also ask for the dimensions? Yes, the dimensions. So the dimensions of the rectangle are going to be, well, remember our height was sine of x, so the sine of x, and then the base is pi minus 2 times x. So basically when we plug those back in, we get 0.65 by 1.72. Sound good, Madeline?